Okay, let's start now. Thanks for coming and coming in time. My name is Jorge Arteiro. I'm Microsoft Cloud Developer Advocate on the Cloud Native and Container space. What that means that I'm the guy that globally talk with the community, bring back the feedback for the team. We develop a new features, bring back for you, all that cycle. I'm not selling anything here. I'm just showing the new technology, Azure Kubernetes Serverless container apps. But today is not about Microsoft only, it's about containers. Okay, containers for .NET developers. And I have been working with containers since like 2014, 15. Then it was nice to see that transition from Docker to Kubernetes, going for the public clouds and become mainstream for many companies. I think it was a journey. In the beginning, many people said, oh, I don't care about containers. Maybe it took 2 or 3 years, they try again. And who never used containers before? Who never did like a Docker run before? Never did, never ever. Never did a Docker run? Okay, it's good. I'm going to do one for you today. Just remember, if on my last talk, that's a community that I created 2 years ago to publish content, videos, blogs. If you have any content that you want to publish, and even if you never spoke before, even if you never presented in another language before, I'm happy to record in your language. There are 2 languages there, Portuguese and English, more English. But because I speak both languages, I'm also doing in both languages, but you are welcome to bring other languages as well. And please subscribe. And that's to join. And if you want to be part of the community, you want to help, if you want to become a mentor to help other people to create content as well, that's what we do. We break the ice. We help people to be part of the community and just say, give me your detail. Maybe it can help some way. Okay? The first thing, a little bit different from what we talked at the first session today. We're going to talk about local development. Anyone using those things, there are a few products there that you can use for local containers development. Docker Desktop, who's using Docker Desktop? Majority. Rancher Desktop, anyone using Rancher? But Rancher Desktop? No one? Okay. I'm using Rancher Desktop here, then it'll be nice to show, and if you never use that. And you're using Kind to create a cluster, to create a Kubernetes cluster? Nobody? Nice. K3D with Docker. Anyone? K3D is one. Those are different ways to create, okay? You can get canonical micro-Ks, where you can quickly create a cluster, even create like a multi-node cluster as well. You can even use micro-Ks in production for IoT environments, for small environments. You can probably a better distribution to use that. And K3S is part now of CNCF, the Cloud Native Computing Foundation, as official, Kubernetes distribution. It's very lightweight. They get all those, Kubernetes components, and they put it in a single binary. And you can have like a cluster with, I think less than, if I'm not wrong, 500 megabytes or something. Like, you can have a cluster running, and that's very nice for development. And Rancher Desktop is using K3S, because K3S was originally done by Rancher. Rancher now is part of SUSE, the Linux distribution, and now they decide to create Rancher Desktop. See, those are the options that we have. And one thing I was showing before is the first thing for the developer to understand about containers is how to package your application. How I build my application. There is no MSI to install. Who is the time from MSI times? That I always have to pack your application, desktop, whatever. Yeah. It's not even on Visual Studio anymore. It's an extension. Now I have to install MSI to create like a a package. Docker image, Docker file is your package. Keep in mind that. If you don't have an image, you don't have application to deploy. You need a container image. A lot of people say it's a Docker image, it's a Docker image. But now it's an OCI, Open Container Initiative, that many companies are part of this. That's part of CNCF, where you create this format that's compatible, is open. But we still call it Docker containers, Docker image, but it's an image, okay? And the first thing you do, like for .NET, for example, you create a base image. For each from, you create one image, okay? When you run a command like docker build, to pack your application, that's what they do. They go for this Docker file, they run the first from, create one base image. Then in .NET, normally we create another one, like a second step, where we call build. Then to build application, to do like a .NET build, you need like a SDK. Then you're starting from SDK 6. You copy your project, you run .NET restore, you copy your source, you build the application, and that's it. And all these blue layers, that's what you call Docker image. If you go on Docker and do Docker inspect and that image, you're going to see all those layers. Those are file systems with all the files changed on each operation that we did on the Docker file. And the next step now is create another front to publish. And then you run .NET publish. Now we have your application build and publish. And you create another step called final, coming now from the base image, because we don't need the SDK. Please don't deploy in production from the SDK image, because it's very heavy. This base image there on the top that we use as base, that's very lightweight. Okay, just a few megabytes. SDK is a huge one. What is going to happen? After I go and I copy my code, the other image can be deleted. It's just like a temporary file that Docker is creating to build, the Docker build process is to create the image. After that's done, we have the command, the entry point, where you're going to call .NET in your application, and that's the final image. Everything disappeared. Everything was just like doing the process of creating the image. But the final result is the final image with only like a lightweight base image in your application on top. Nothing more. And that's what goes to production, and that's why we have to learn how to build that. Then let me stop here and show a few things on my local environment. The first one, I'm using Linux. I'm on Windows, but it's all WSL. Who's using Windows Subsystem for Linux here? If you're not, give a go, because everything that you do in development these days will be Linux. We're going to see Azure Container Apps, the new application here. There is no Windows containers there. It's just Linux containers. Okay, we don't have, estimate to say Windows containers coming. It will be Linux containers. .NET 6 now, .NET 7. I mean, you can just migrate your application. You can run now on Linux as your server. The legacy is there. There are a few options to deploy, full .NET framework. But for .NET Core, for pretty much all the other language, you'll be on Linux. And if you never use Docker, like I said, never use Docker, that's the Docker command line. If I do Docker, you can see all the things that you can do with the command line. And a simple one is Docker run. I want to get like a shell, an interactive shell. And let's do like a Nginx. And let's put like port 89, going to port 80. See what I'm doing here? I'm running a container. There's no Kubernetes here, just Docker. Okay. I'm asking to map port 8090 on my machine to port 80 on the container. And I'm using Nginx, like a base Nginx image. There you go. Nginx running. What I do, go to the browser. Localhost 89. If you never did a Docker run, now you know how to do a Docker run. Just install Docker Desktop or Rancher. In 5 minutes, you can, or maybe 10, depends how long it takes to install. But you have this. Then, how many I can do it? Because I put it interactive, but let's open another one. Docker run, you can run detached, and you can see Nginx. What is that? 87 maybe. Whoop. Going to port 80. Nginx. Ooh, I put a lot of command there. Docker run -d -p Nginx. There you go. I create one. If I do Docker ps, I have my command, my container running there on top. Nginx. And now we can go port 87. I think I stopped it because Nginx 87. Let's see if it's still running.
Might need to change the port.
Yeah, I think the port number, maybe I'm using for something else. I've done a few things. But just, which one?
The error message says unsafe port. I think 87 is a bad choice.
Yeah. There's probably conflict on the port. But anyway, you got the idea. You can do that as many as you want. How people do it? Anyone want to say here? Who is a developer is using Docker? How you do it? There's one thing called Docker Compose that you can, define how you want your application. Have the front end, will be a web application, like that. Then have like a database maybe a SQL Server running locally. And there is another thing, say Docker Compose app. They got that definition, and they do the Docker run for us. That's what they call Docker Compose. Simple like that. But you can also define a network and say, okay, those two containers, they're going to talk with each other inside like a VNet. Docker Compose is very nice to do that. And there are a lot of people using that. You're going to find, if you're a developer, if you move to a new job, you're going to find a lot of Docker Compose around, the code. It's like a makefile. You have a definition there, how to create the things. A lot of people do with makefile. Okay? Just do like a make and have like Docker run there. There's nothing wrong with that. I'm giving options here for you to understand how we're going to find those things in your job, in your, in the next project that you get. You have to understand that, because without that, you're not going anywhere. And that's the Docker one, okay? And the same thing for the image, Docker image, you can get the image that you can download. Docker pool, you can get the image. But that's like old school, okay? Nobody's using Docker anymore. Just for development, just for local development, yes, you keep using that. But in production now, we're using Kubernetes. Then we can get the same image that you can do like a Docker build here. And if I go back and stop that, I'm inside a project here. See, is that not that project? I can do something like that. I can use Docker build X, and I can do something like that. Let's get the right one. Yep, let's see. Test. You give a name for that, and that dot at the end, ask them to look for the Docker file inside that folder, the folder that you are. In this case, you can see there is a Docker file there. Yep, here on top. Then when I click there, I'm going to build the image. And that's the Docker build. You see the slide that I went for all the layers, all the fronts, and all the layers? When you do the Docker build, that's exactly what happened. You're going to the Docker file, you're going to do exactly what we did manually there on the slide. And you can learn and see what they do from the logs, and there is a docking spec that you can do and look the image as well. That's very nice for debugging, for when someone asks you what's on that image, you can see how many layers you have. You can try to compress the layers. But one nice thing here is Docker kind of cached the image. That's why it doesn't take the same time when you build the second time. The first time I built that took longer. I had to download the base image from like a registry. It's like who is a JavaScript developer, like a package, any package management that you use for JavaScript, you have to download, NuGet package. You have to download this base image from somewhere. There's a repo there. We download that image, and we use that to build our application. And that's take time, but once you have this in cache, that's fast, because there are a lot of caching on those layers. And it's not very common for Windows people to understand that, because in Linux, everything's a file. In Windows, it wasn't like that. Like from Windows 2016 server, they changed a lot to make Windows be like similar to Linux on that aspect. And they had to include like registry, they had to include all the files. And now you can do a Docker build, also create like a container for Windows containers as well. I'm not going, I talk a little bit about Windows containers on the previous session, but not on that one. And that's Docker in a nutshell. The only thing you have to really use from Docker now is a Docker build and maybe a Docker compose locally if you want to play with something. And a nice way to show that is code space. Let me restart my code space. Anyone using code space, GitHub code space, is a container. It's nothing more than a container. And if you don't know, Visual Studio Code now can run inside the container. Okay? Visual Studio can run inside your Windows, can run inside Windows Subsystem for Linux, that's Linux, and can also run in a remote machine, and can also run inside the container. Then you have to install that extension, show here, Remote Explorer, and you see the targets on the top. Code space, containers, SSH targets, that's like a remote machine, and WSL, Windows Subsystem for Linux. Every time that you find like any repo that shows something like that, dev container, see that folder, .dev container, that means that is a container that like Visual Studio Code is running in a container. If you can use that same dev folder there to open this whole repository on Visual Studio Code in your machine. Create a container from that definition. And if you go inside that dev one, you're going to see there's a Docker file there. And that Docker file is my environment, in my developer environment now. Now I can use Docker. Yet there you're still using Docker a lot. Code space is using Docker everywhere. That means that you can now write down what you want in your developer environment. And that's what's nice in code space, but you can do that in your machine. If you create a dev container, there are documentation, you can go there. You can define what you want, all the libraries, the language that you're using, all the CLI. They're going to create this container image, that's your development environment. Now you're going to work inside that container. Then when you open Visual Studio Code, they're not running in your machine anymore. Looks like that's running in my machine, but it's not. Look here at the bottom. Code space. Look the other one, WSL 2204. Maybe too small, but at the bottom here in green. That's where they're running. When you open, because Visual Studio Code is a web application, they're going to install all your environment, including extensions. You can define on that dev container extensions, everything that you want. Using that base image with all your tools that you prepare there, and you have your environment. And we have been adding dev containers in a lot of Microsoft repos, open source projects. And just pay attention now when you see a repo, and you're going to find that there are a lot of dev container folders there. But there's another thing here. There's one extension called Docker. The same thing I was doing on command line there. Docker PS, Docker, you can do here from the command line. I can see the image. Let's go this down. I can see the Docker image, Alpine, Nginx, Debian, even my API, NDC Melbourne API. And I can see everything that's running. Those are containers running on my machine. Can I do more? Yes. You can now go and see your Kubernetes clusters from here. Then I have something called, that's the IAKS cluster running on Azure. That's the first one. And I go workloads, deployment. It's probably not connected. Let's see this one. And I have, let's try my local one, set current cluster, nodes, there's my Rancher desktop. Hang on. Yep. Let's refresh here. I don't know what happened on my Visual Studio Code, but the extension sometimes can crash. Let's see if my class is running. How can I check if my class is running? I use the Kubernetes command line. Do get all dash capital A means that I'm going to get everything that's running on all Kubernetes namespace. Yeah, it's running. It is running. And that's my Rancher desktop cluster. And that's exactly this cluster here. When you install Rancher desktop, you have this environment here. You can connect with your Windows subsystem for Linux. Means that they're going to give us, the kubectl, the Docker CLI. They're going to give everything for us. You don't have to install yourself. You can create a cluster, not just Docker. You have two options. You can use Docker, Docker-D, that's open source, by the way. We call Docker-D Moby project. Or you can use Container-D. Many people are asking that Kubernetes not using Docker-D anymore. Yeah, that's true. They're only using Container-D. And if you want to go, forget about Docker, you can use Container-D only. And there is another command line called netctl that replaces the Docker CLI. Then you don't even have Docker command anymore. It'll be netctl run, and you run the container. Okay, and probably that's what's going to happen. But what happened here? I can create any Kubernetes cluster to work, on my local machine or inside code space as well, because using kind, remember the other one called kind? I can create my cluster inside code space. See, I'm giving you options. Here is Rancher desktop, is running on my Windows, and I have a cluster running. But I also have a cluster running inside my code space. That's my machine. I have a repo with code space that's on the cloud, on GitHub. And I also have, I think I have kind here. get clusters. Yep, I have one cluster. If I go to the extension, there you go, this one's working. If I go for this workspace, you can see code DNS running there. That's code space, not on machine. That's on GitHub. I have Docker here, and if you do Docker PS, you have Kind running. What Kind does, they create one whole cluster inside the Docker container. They create this container, and now they create a cluster inside that. And you can create as many as you want. You can create clusters with different versions. You can create a cluster just for pipeline to do like a test. You can run your whole test and destroy the whole thing. And there are a lot of people doing that. Because lightweight. They go and run the test, do like all integration tests if they want, and destroy the whole thing. That's on code space. And this one is on my local environment. The nice thing that I like on Rancher Desktop is they can do port forward for us, because Rancher Desktop on Windows, they run inside Windows Subsystem for Linux. See, one thing inside another. Then we have to do the port forwarding for Windows, for your application that's running inside there. Then they made that easier for us with port forwarding here. And they also included, container image scanning. Container image scanning is, you did that Docker build 5 months ago, but you have to keep updating. It's like updating your Linux, your server. You don't update the server anymore. There is no patching with containers anymore. What do? You rebuild the image, and you publish again. It's immutable. That's what CNCF Cloud Native is. You rebuild and you publish again. Then on Azure, on AKS, there is a ways to automate this process. There's Azure Defender now that can be doing like live scanning on your applications running on AKS. And once they detect something, they alert, they even can trigger a pipeline, and you can rebuild and redeploy the application. Everything can be automated. Okay, and Azure Defender is available for AKS. And you can use like Azure policies on AKS to also say what Docker image can be deployed in your environment. You want to avoid that someone go there and deploy an old image. You can just allow a specific image or image coming from like your private repository, not like from a public place. Then you make sure that nobody's going to publish anything in your cluster that's not safe, that's not coming from like the source of truth, and not coming from your pipelines, not coming from all these scanning processes that you have in place. I think that's a big one. That's the Rancher, but Rancher Desktop has one thing called dashboard. If you don't know how to open, because many people don't know, you right-click here and click dashboard on the clock. And that's pretty much like an extension that we have on VS Code. You can see the whole workloads, cluster, everything. You can see pretty much the whole cluster. Let's say deployments is pretty nice. You can even create a deployment from here, like this. Okay, so Rancher Desktop I think is a very nice option and for local development. And you can have all as well. You can use the Visual Studio Code extension, the Docker as well, the Docker Compose. I think you're going, at some point, use all of them and give you a little bit more options. What more from here? Let's go back for my slide a little bit. Any question on that before I go for Azure Container Apps? Makes sense that, like, help a little bit. If you never use containers, question?
Right at the beginning, when you were showing the multi-stage build pipeline, did you publish a separate step build? Why was that? Why did you do that?
The publish?
Yeah.
Yeah, there are different ways to do it, you know. Because the publish there is just like a copy. At the end of the day, we're just copying. And maybe we could do Docker publish inside the same one and do, yep, that's fine. I don't see a reason. I think it will be clear, it will be, okay. Make sure that on that step, the only thing you have there is the publish. Then make sure that nobody is going to copy anything else. I think it's more to avoid that. Because imagine if there are a lot of things there, someone can just start copying things. Once you do, the only thing you'll be on that, you know, publish should be the publish. There's nothing more like code or anything. Then I think that's the main reason. Make sure that you know, like the final one is not even not looking to the SDK one. That's building the application. And you make sure that nobody's touching more than you should. And the only thing you run there is the publish command. Yeah, I don't see many reasons, but probably. So using what? The advantage of using containers. Nice one. The first one is isolating your dependencies. Okay, like when you have a VM, you have a lot of stuff there that you don't need it. Yeah, you can using things like Hashcopeka to build the image that's only minimal and put your application. But the containers, one thing is that dependency, you can just put what you needed. Another thing is container, they share the same Linux kernel. They are like a operating system isolation, different from Hyper-V or another like a VM. That's more like hypervisor isolation. And that's very lightweight. That boots like in less than a second. There are some containers boot like in microseconds. And that millisecond, microsecond, boot, like to start a container, all that Docker image caching, everything makes the thing be faster to boot. There's a lot of techniques, and keep improving. I think for me, that's the main advantage. Like many years ago, like in .NET framework, you could not install .NET framework in the same computer. Like you have to upgrade the version. You could not have two versions on the same machine. .NET Core you can, but yeah, and that brings like security problems, a lot of other things. Only that for me, I think, makes sense. And the way that you scale, because lightweight, you can just boot very quick. You can scale up and down all the time. And you don't do patching. If anything changes, you just rebuild the image and redeploy. Because fast, because you can. And I think that's what many people like in containers is that. And then come Kubernetes as an orchestrator that, okay, now that we have these containers, and by the way, containers are there for a long time, since like, Solaris, and they just keep improving. People start creating libraries, and then Docker came and created like a even easier library to be used, and then become popular. But I know companies like Telstra that use Solaris, how many years ago, maybe 20, maybe more than 15 years ago, and then those isolation by kernel is something that's there for a long time. I mean, became popular now. And it makes sense. Otherwise, it wasn't being used by all the cloud providers. In some point, what's going to happen? You're going to use containers you don't even know. For example, Azure Container Apps. You're going to deploy application now. You're going to see exactly Azure Container Apps next step. Then you're going to understand what I'm saying. Let me go this one. I think, yeah, that's Container Apps. Now, that was like 5, 6 years ago, containers was the beginning. Now, they are everywhere. And now we are building things on top of containers, on top of container orchestrators, on top of Kubernetes. And that's Azure Container Apps. We try to simplify, but still there. Kubernetes still there. Keda, Dapr, Envoy, they're all CNCF projects. We have these serverless, what you call serverless container for microservice, for modern applications on top of Kubernetes, and these other projects. And what you can have with that, you can use any language because you pack inside a container, it's isolation. It could be running now any language that you want on the same host, complete isolated dependencies. How you do that on VM? And if you want to run .NET and Java on the VM, and Python and Go, like, I don't know, like any dependency that you have for those applications have to install everything together. In a container now, they could be all running on the same physical machine, but complete isolated, and each one can see all dependencies, complete isolated. And that's the nice thing of container apps and Kubernetes as well. Any language for production, for microservice using something called Dapr. Who watched the Dapr session that we had here before? Anyone watched? You had one? Yeah, we had a session on Dapr. Dapr is nothing more than .NET Enterprise Library. If anyone is old enough, use .NET Enterprise Library. You use that? Use that? .NET Enterprise Library. What was that? Caching, identity, yeah, authentication, things like that. It was like a library that could do a lot of things. And it wasn't on .NET yet. Then people started to create these libraries that we could use, and there is a lot of, became as like a guideline and became a library or something. People said, oh, let's create like, it was more like a guidance library that became very popular and became like something. And Dapr is like that. What we need to develop cloud native applications, we need that communication, TLS communication between the microservice. We need someone to manage the certificate, that communication. We need to talk with like a pub sub, like Redis cache. We need to talk with Cosmos DB. Everything that you can remove from your application code and create this library that can and do a lot of things. If it's good or not, it's up to you to decide. But you can use it even using Dapr, just copying the library and using that. But what they're trying to do, you don't have to install these 100 SDKs to talk with all these other products. You have one single library that's called Dapr. But the way that we deploy that, is a cloud native way. And in Kubernetes, we deploy Dapr as a sidecar container. A sidecar container is my personal assistant here. Okay, I have my application running inside a container, and when Docker creates a container, they create like a namespace. That's exactly what isolates the container from the other container. They create like a namespace. They create a C group in a namespace, and then you are isolated here. Then inside that same namespace, they create another container, another process. A container is a process for Dapr. And we talk with Dapr by GRPC. That's very fast. It's kind of, they're not running together. It's a separate process, but it's a fast communication. And I say, Dapr, I want to talk with that microservice. I want to talk with that microservice. I want to talk with that microservice. Then Dapr is going to inject I don't know where you are. I know that I want to talk to you. Okay? You are the microservice that I want to call. I ask them, they know where you are, service discovery. That's one thing Dapr does, service discovery. Then you can integrate with service discovery even outside your cluster. There are companies using third-party service discovery products. And then just do that. I want to save this pub sub on Redis cache. Who's using Redis cache? That's very popular, Redis. For caching, for session, for anything. You can do that with Dapr. Just say, I want to send that. But you could do that in development. Then imagine when you deploy for one customer, the customer say, hang on, we don't use Redis cache here, sorry. Your application is not going to be used by our company because we don't have Redis cache. But Dapr only, can talk with Redis cache and many other pub/sub solutions. Then you don't have to change anything in your application. Your application will be going to be able to talk with these other products that are compatible with Dapr. I think that's what Dapr does, is a library. And I recommend you to have a look and give feedback, because there's a lot of to be improved there. And I'm saying that just for you to see how the container apps is growing. Then was built on Kubernetes, Dapr, and another one called Keda. Keda is, how are you going to scale those applications now? How you scale application on Kubernetes? How many requests you have received? If your CPU is like 9%, if your memory is on the top, using all the memory, how are you going to create another instance? Horizontal scaling. How are you going to do that? Then, this project was born at Microsoft exactly to fill this gap, and now it's used by everyone. On the community, it was donated to CNCF. And now you can scale for things like message queue. There is 100 messages on the queue. You can scale your application based on how many messages you have on the queue. And I have an application here to process that message queue. Every time that there is 100 messages, I create a new instance. There are 500 messages, I create 5 instances. And I keep scaling up and down. Kubernetes containers very fast, scaling up and down, milliseconds process, bang. Sometimes runs for seconds. Sometimes runs for microseconds, milliseconds, depends on your application. And it's not doing anything, scale down. Because you can. But if your application takes 1 minute to scale up, to be ready like a old Java application, then that's the reason some people start using .NET Core, the latest version that's very lightweight, very, boot very fast, Golang, Rust, because they can be faster than, But Java now is coming back as well. It's very fast to boot, the latest Java version. I had problems like Java 8 and 9, like 8 was very slow. It took like a minute to boot like a container, but not anymore. See, all the languages are getting ready for containers now. They're all pretty much ready. And there is no excuse. Like Azure has a service called Azure Spring Boot, or Spring Cloud. There's a partnership with VMware. And we deliver like a whole Spring Cloud environment that runs on top of Kubernetes as well. And you can deploy your Java applications. If you have Java applications, Azure Spring Cloud is like Azure Container Apps for Java. It's a platform using VMware technology delivered on Azure. And but the main thing I was saying for him was application portability, hosting, and all that Keda, Dapr, and Envoy. Envoy, if you don't know, is a lightweight, reverse proxy, and then everyone is using our Envoy proxy on the cloud native because you can. And we using that, all the ingress controllers, all the traffic go through Envoy. And it's open source on CNCF as well. And what was delivered at MS Build? At MS Build, we released all these main features for Azure Container Apps and GA, by the way, you can use in production now. And I think it was the first product where we really delivered pretty much all the enterprise features from the beginning, from the GA date. Because look there, what do you have there? VNets, managed identity, logs, custom domains, all the probes, Visual Studio integration. That's just what was released at the build, but the other things are already there. Volumes as well in preview, you can attach files. Means that pretty much everything that you do on app service today, you can move application here. I don't recommend you start with Azure Kubernetes Service. I recommend you start with Azure Container Apps. And if you need something more advanced, like Service Mesh, Azure Policy, or something more there, a different network topology, you maybe need Azure Kubernetes Service. But what you have there, you have the same thing that have Azure App Service, easy authentication. You can have easy authentication. Means that, OpenID connectors there that are available. You can move the same way here. And that authentication is kind of hides identity and hides all the the authentication authorization for your application on that layer outside your application. That means that you're not going to write a lot of code if you don't want. You can manage it all on that configuration level here. That takes a while to do the authentication right, in my opinion, because if you never have done, and most of the developers, they start application without anything. There's no authentication, no, we're just prototyping, there is no authentication, there is no authorization, there is no certificates, there is nothing. How about starting with that from day one? You can now. They manage secrets, they manage ingress controllers. Ingress is all the traffic coming, means that there is like a routing with Envoy proxy there. It's all HTTPS out of the box. Continuous deployment. You can do kind of a GitOps. You can configure like a Git repo repository every time that something changed there. They're going to get your Docker file. They're going to rebuild the image using Azure Container Registry build. If you don't know Azure Container Registry, there is a build option there. They're going to build that inside Azure Container Registry, keep the new version there, and going to redeploy application. You don't have to have anything. Okay. They're going to configure like GitHub as well. Another way, you can bring your domain, you can bring your certificate, and Dapr and Keda, they are out of the box there. Means that we can just define what you want to use from Dapr. I'm going to show later. Manage identity. Service Connector is a new thing on Azure that allows you to connect your application with other Azure services, like a SQL database, a Cosmos DB. Still in preview, but I think that's going to be across Azure, not like Azure Container Apps. Means that you're going to simplify that communication between your Azure Container Apps and those other services like database. And it was released, I think, 2 days ago or something. Azure Static Apps. The Static Apps now, you can pass the authentication for your microservice running on Azure Container Apps. And you can integrate that authentication there, even authorization with the scopes. And there's an easy way to do that. It means that you could run your front end, if it's just like a web application, ship away, and run all your backend APIs, microservice on Azure Container Apps. And they can talk with each other nicely. It's another way. Another thing people use is revision. It's very similar to slots on app service. Means that there are 2 ways here. One is single revision. Every time that I deploy, I override the previous one. Another one is multiple revisions. What that means, I always deploy a new version. I keep both running, and then I can split the traffic if I want. If I want to send 20% of the traffic to the new version, just to see how that goes, and keep the V1 running there, you can do that. You can split the traffic until you move all the traffic to the new version, then you can safely remove the old version. That's very nice. I think app service you can only swap, but here you can split the traffic. Scaling, you can use anything that Keda can do. That's a lot. I'm going to show on the next slide. And all the monitoring logs, you can even connect inside the container to see what's happening inside the container. Apps. And it's all going to log analytics as well. And you can even console. You can log in and do do whatever you want inside if you want. And those are the applications that we're talking a lot, for Azure Container Apps is microservice using Dapr, like I was talking. Simplify communication, simplify anything that you want. I have some slides. If we have time, I can show a little bit more. Revisions means that you can deploy V1, V2, V3, and keeping, you can do like a canary deployment where you're going to send like a small percentage of the traffic, blue-green deployment. That's the only way that you really can can guarantee that your application will be, no timeout, will be 100%, available all the time. Is doing like that. That's exactly how Kubernetes works. Web application, there are many options for that. But if you need a web application where you can scale to 0 and don't pay anything, that's the only one. Don't tell anyone that I said that. But Azure Container Apps is the only application that scales to 0 and you don't pay anything. AKS can do that? Yes, you can. But Azure Container Apps is the only one that you can keep one instance running and you pay just like a small standby fee. Then you can look on the price for Azure Container Apps, and there's a standby fee. What that means, if there is no HTTP request coming from your application, like the whole night, you only pay that standby fee. You don't pay the full price, just because you want to keep one instance running. But you can scale down to 0, like Azure Functions, for example. Yeah, you can. If you just like process like a message queue, when I finish processing, I scale to 0, don't pay anything. I have a few deployed here that I'm not paying anything because it's all, nobody's calling. And there is no cost, scale down to 0. And if a website that can, start up like in 3 seconds, it can even, because they're going to keep retrying. If your application comes back very quick, in milliseconds, they can scale to 1 and works like that. That's why it's smaller, better, because boots faster. Another one is background processing and eventing process as well. That's what we talk about: message queue, event bars, anything that you want to talk. I'm not going to skip this one, but like that you can create a container environment, and you can define another thing that's very important: zone redundance. In Sydney, we have, in Australia, East, we have zone redundance. And that's out of the box on Azure Container Apps. It means that if there is one zone inside, Australia is failing, there still be another region running your application. And that's on day 1 there. Then you define monitoring, log analytics, like I said, and networking. And you can do internal and external. Could be completely private network. And that's what they call environment. And have inside that environment, like a app service environment. Let's compare. But we have that environment where you deploy your applications. They're all inside the same network. They can talk with each other. And that's how that works. And our revision, that's like a deployment on container apps, is a pod. And a pod in Kubernetes, like I said, they can have multiple processes inside that isolation there. And you can run sidecars, you can run, anything that you want to run inside that pod. And you can have multiple revisions inside the same container app. Container revisions, the GitHub actions that I was talking about, container registry, and GitHub actions, they create that for us. Secret management, logging, and that's just like a demo here. But I want to go from one slide here at the front. We probably best to show. Yeah, because we talk about Dapr, that's what the Dapr is for the options that we have on Dapr. PubSub, secret management, service invocation, state management, and something like that. You can have this sidecar container, they call Dapr there, on each side. And you can make this personal assistant to do all the job for you and to find out where the other service is. There is service discovery there. Observability, they can talk with Zipkin, Jaeger, App Insights. Then you don't have to write this code. You just configure Dapr, and Dapr is going to send everything for any of those products, and probably more in the future, because there are a lot of people doing integration with Dapr. Then we don't care about this code anymore. That's nice. They use OpenTelemetry. PubSub, like you see at the bottom, Kafka, service bars, Was that RabbitMQ, Google Cloud Pub Sub as well, Amazon SMS, the message queue there. Means that you don't write this code. You just say, my personal assistant, he knows how to do it. I just ask him, he can do it. That's Dapr. That's a library. Secret management. Anyone using HashiCorp Vault? I'm pretty sure there are people using Vault. Yeah. And then Azure Key Vault or Vault. I think all the big enterprises, they use Vault. Then you go there with your application, with your knowledge, and they're going to ask you to integrate with Vault. If your application is already doing that, simplifies. Doesn't mean that you have to use Dapr to use Azure Container Apps. No, not at all. You can just disable and not use that. Okay? It's just like an option that we're giving there for free and you're installing, but you can manage everything yourself. There's no requirement for that. Yeah, but you can use Dapr for all these things. And like I said, the cloud native on Azure is OpenShift, Azure Kubernetes Service, Container Apps, Functions, Spring Cloud, Azure Spring Cloud. And there's one thing that is on here, there's the new hybrid that's called Azure Arc, where we can now have a single pane of glass where you can manage clusters running everywhere. And there is one AKS called Azure Kubernetes Service HCI. That's for on-premise. Now you can get AKS and you can deploy on Windows Server on-premise if you have to. My application cannot be public cloud, has to be running on-premise. No problem, you can use AKS as well. And you can use Azure Arc to manage clusters running on Azure, or another cloud, on-premise, from the same place, including apply policies from a single plane. That's what they call Azure Arc. And let's see. I think we don't have much time, but questions? We can have questions.
So if the container you write to the file, that file will be in the container. So when you want to have the web, what will be the information is saved in that container?
Sorry, say again?
So if you have a container, say the file which is inside the container, and then you want to upgrade to a new version of the container,
Yeah.
what do you do with the data saved in the container?
We don't, because one of the things with application to be completely stateless, you don't want to keep any state inside the application anymore, like you used to do with VMs, save files. And Dapr help with that, because you can get these out of your application, and you can use blob storage, Azure Blob Storage. You can use Redis Cache. You can use any pub sub, messaging system, message queue, to get all this information outside your application. Your application should be just running there completely. There's no state there. They're just processing the requests. Once they finish processing that, they can just shut down. Yeah, and that's not about container. That's like you should be doing that for any development that you're doing in VMs or anywhere. Don't save anything on the disk. When I say that we have volumes, like Azure files, they're not inside the container. They're outside. We can map Azure files multiple times in multiple different containers, instance. The same folder we can map, we can mount. Then if the container dies, we just mount again on the next one when we release the next version. But the container should be completely, no state there, no files, anything. You can have like temporary files, do processing, but nothing that you cannot lose. Or you attach like a volume that will be outside. And that's why Kubernetes has all these volumes. And now on Azure Container Apps, we have, you can have like a ephemeral disk, or you can have like Azure file somewhere. Then, if you do that, you're safe. You can do the same for Azure Container Instance. Now you can do that for App Service. That's a nice thing, because App Service was kind of causing this problem because they have a big disk there, and we just chunking things there. Now they did like integration with, I think, Azure Files, and you can save that outside. And
On Azure Hub, it's website that has there is a one like it's MySQL. So I wonder where does it store the database?
That's why normally people don't do much things for production, like database, where you need a lot of storage in containers. We do, but we have a way to manage, to shard all the load, all the storage. And for you to do that yourself, I don't recommend. Just get like Cosmos DB, SQL, or any MySQL fully managed by the cloud and use that. Because storage is pretty hard, like volumes have to extend the volume because you never know if the database is going to grow fast or not. It can get a lot of load suddenly, and I think database hours are going to be outside, and you talk to that. And that service connector will be easier to talk, like that at least authentication. And you can do it. Like a lot of people run all these things on containers, but you have to make sure that there's one thing called stateful sets, but that's more for AKS, where you can, on AKS probably be the best solution if you want to run something like that, not on container apps. Unless you are happy with Azure Files, or in attaching Azure Files, the performance will be good enough for what you say. If it files, it's fine. But for database, you probably need a better performance, and then those blob storage things are not going to be probably the best performance for database. Then you need like Azure Disk or something. And on AKS, you can attach Azure Disk on your container. That's the difference. And that's why for this kind of database or anything that needs a lot of storage, go for AKS. And now we have this, they call CSI driver, where you can have Azure disks and even extend the disk and snapshot the disk. You can do a lot of things now that wasn't available before. And it's getting safer now, because we're doing that for ourselves, and then the customers are going to use. But I'm not sure. I think we are over time already. If you want to leave and question that, no. Thank you, everyone. Appreciate it. If you want to